हेलो स्टूडेंट्स, माई सेल्फ अनूप वर्मा। और यहाँ पर हम हायर मैथमेटिक्स को डिस्कस करते हैं, तो आप हमसे जुड़कर हायर मैथमेटिक्स को सीख सकते हैं, समझ सकते हैं। अभी हम लोग इंटीग्रल कैलकुलस का पेपर पढ़ रहे हैं, तो उसी लेक्चर सीरीज में आगे बढ़ेंगे। तो आज हम डिस्कशन करेंगे मीन वैल्यू थ्योरम्स ऑफ इंटीग्रल कैलकुलस। तो देयर आर 3 or 4 थ्योरम, देयर आर वेरी इंपॉर्टेंट थ्योरम्स। So I will discuss the statement of the theorems, okay, in this lecture. So let's start. The first mean value theorem is what? So let's write the first mean value theorem. Mhm. FIRST, first mean value theorem. ठीक है, ओके। सो लेट अस सी कि फर्स्ट मीन वैल्यू थ्योरम क्या कहती है। सो इफ देयर इज अ टू फंक्शंस fx and gx, I'm taking two functions fx and gx. If fx and gx are two functions are bounded and integrable in this closed interval a comma b. Okay. One thing is this, कि both are the function bounded and integrable in this closed interval a comma b, and this second function gx and dx maintain the same sign, the same sign in it. It means that कि a से b तक की वैल्यू, या तो a से b तक x के लिए या तो एफ एक्स हमारा निगेटिव दे रहा है या फिर पॉजिटिव दे रहा है। ठीक है, दैट इज योर सेम साइन इन दिस इंटरवल। ओके, then we have a result. What is the result? That integration of a to b of fx dx into gx is just equal to mu times integration of a to b of gx to dx. ओके, सो अब ये म्यू क्या है? म्यू इज सम पॉइंट बिटवीन द बाउंड्स ऑफ द इन्फिमम एंड मिनिमम। मतलब एक हमारे पास म्यू वैल्यू है जो कि इसके इन्फिमम और सुप्रीमम के बीच की वैल्यू है। तो दैट डेफिनेटली एग्जिस्ट सम म्यू which satisfy this integral from a to b fx dx is just equal to mu times a to b of gx dx. Okay, so where you can just write here, where mu is belonging to the interval small m to capital M, जहां पर small m क्या है? इन्फिमम है फंक्शन का fx का in the interval a to b, and capital M the supremum. Okay, so where you can just write here, where m and small m denoting the least upper bound, it means supremum, and greatest lower bound, that is called infimum, GLV of fx, ध्यान दीजिएगा, of fx in this interval a comma b respectively. Okay, got it. So this the first mean value theorem in the integral calculus. So what the theorem is saying, if both the function are bounded and integrable, and the second function gx maintain the sign, if it is positive throughout that interval, or it is negative throughout that interval. Okay, in that case we definitely able to find a number mu in the between the infimum and supremum of f in this interval, such that this will be equals to mu times a to b of gx dx. Okay, so this is the first mean value theorem for the integral calculus. Okay, so in behalf of this theorem, we we can able to write a corollary. Let's write. So if we just took that function is continuous, okay. So what we'll have to repeat. Okay. So if okay, so if a function is continuous, so let's write a corollary on behalf of this theorem. So if I'm just changing the color of the pen. Okay, so if in addition, if we just took the continuous function, suppose that in addition to the conditions of the above theorem, I'm just took fx is continuous. This is fx be a continuous function. Continuous on this closed interval a comma b, and this gx be a non-negative integrable function. Non-negative means it is not negative. Integrable function. Okay. Function on this closed interval a comma b. Then there is a point. There exists a point. Point C, which is belonging to this interval a to b, such that this integral becomes like this. This is a to b fx gx dx is just equal to f of c times. So this is actually mu. So mu will be equal to f times of fc. It means if value of the fx at c point, and c is between this a comma b. Okay, so both the theorems proof is very nice. Okay, so if you want to learn more and more, just try the proof by self. Try proof by self. So if any one of you want proof that, sir, please prove, and I need the proof of this theorem or result, so please comment. I will provide the proof of also, but for the course purpose, for because we are learning the MCQs, and for the English, so we are not going in detail of the proof, but you just try by self if you have time, and also try by the self proof. Also in your textbook is proof is written, so you just understand how we can say that the limit a to b fx fx into gx is equals to fc times a to b of gx fx. So here the two condition added. One is fx is continuous, and this gx be a non-negative integrable function. Okay, so it's try by self. Okay, next we are going for the second mean value theorem, and there are two theorems in this. So second mean value theorem. Mean value theorem. Okay, second mean value theorem. So in this there are two theorems. Theorem has two forms. So one is Bonnet second mean value theorem. and second is your Weierstrass second mean value theorem. Okay, so for this, let's understand a lemma that's called Abel's lemma for the proof of this theorem. But I just uh, read out the statement of these both theorems. Okay, so first we learn about the Abel's lemma. So in fact, the Weierstrass form is generalization of the Bonnet form. Okay, so Weierstrass actually generalization of the Bonnet's second mean value theorem. Okay, so the proof of the theorem depends on the Abel's lemma. So I just also recall to Abel's lemma, but I am not going to prove because it's not needed much. Okay, but you just try by self also. So Abel's lemma is what? Let's understand about the Abel's lemma. What the Abel's lemma saying? So this saying about if there's a conditions, number first condition that if A1, A2 up to an each are monotonically set of n positive numbers. Okay, I can say this is sequence of some positive numbers. So this is monotonically increasing decreasing numbers. Okay, so this a1 a2 an are the positive numbers and which are decreasing in this order. Okay, so each are monotonically decreasing set of n positive numbers. Okay. Okay. Second condition we have that this V1, I'm just taking V1, V2, V3 up to Vn. These are any numbers, any n numbers. Here we just took n positive numbers, which is monotonically decreasing, and in another case, we are taking n V1, V2, and V3 and Vn are the n numbers, any numbers, is positive, negative, whatever the number, we are taking n numbers. So each set of any n numbers. Okay, any n numbers. Okay, in the third way, in the third condition, the small k and this capital K, okay, are two numbers such that in such a way, to number in such a way that is v1, if you are adding this v1 plus v2 up to some vp, okay, that is less than capital K and is greater than small k. Okay, and for any p is any number between this n and 1. Okay, so for any number of points from this set, if you are summing them, then I'm choosing capital K, which is the sum is less than that capital K, and I'm choosing small k, that the sum is greater than that small k. So in such a way, we are choosing capital K and small k. Okay, for any p, I'm just taking any points in this from 1 to n. Okay, in that case, then we have a condition that what if you are just taking r is equals to 1 to n summation, and you are multiplying this is ar and br, which is less than this is a1 times k. Wait a second, I'm just taking. And this is greater than this is a1 times small k. So if you are multiplying these points, n points, with these positive numbers, which are monotonically decreasing, so I'm choosing the greatest one, that is your a1. Okay, and if you are multiplying with a1 with capital K and this a1 with small k, the sum, which is multiplication together, that definitely lie between these two values. Okay, if you am taking, if I'm saying this is small k is your capital M. Okay, if you am just saying this is your some number which is capital M and this is some number which is small m, then this sum will be lie between these two values. Okay, so this is the lemma that lemma is saying. So you can try with some numbers. You are choosing some number in such a way with following this condition, three condition, then definitely this sum will be lie between two numbers. Okay. So let's try to write the Bonnet second mean value theorem. Okay, so Bonnet's second mean value theorem. So if fx and gx are bounded and integrable this closed interval a comma b, and this gx is positive and monotonic decreasing in the same interval, and then there exists some point, then there exist a point t in this interval a comma b, such that this is from a to b of fx gx dx is just equal to g of a times from a to b of fx dx. Okay, so this is the result, which is the Bonnet second mean value theorem. So fx gx the two bounded and integrable function in a comma b, and gx is at the positive monotonic decreasing in the same interval. Then there exists a point t in this interval such that this a to b fx gx dx is equals to ga a to b. So I think this is not ga; it will be a to t. Okay, it will be a to t, not b here. I'm just taking here. It will be t. Okay. Okay, so this is the Bonnet second mean value theorem. Next, we will just some I'm just taking Weierstrass second mean value theorem. Let's talk about the Weierstrass second mean value theorem. So what is it? So Weierstrass P-I-E-R-S-T Weierstrass second mean value theorem. Okay. So what this theorem is saying, ये क्या कह रहा है कि if wait a second, if this is fx and gx are bounded and integrable in this closed interval a comma b, and if gx is monotonic on this closed interval a comma b, then there exists a point t such that we have this integration from a to b fx into gx dx is just equal to g of a integration from a to t of fx dx plus g times b integration from t to b of fx dx. So this is generalization of the Bonnet second mean value theorem. Okay, where this t is some point, where this is t is some point in this interval a to b. Okay, so this is your Weierstrass second mean value theorem. Okay, let's discuss some problems on it. Some questions on these theorems. Okay, so let's try to do that. So I'm just writing one problem here. So one question I'm just writing here. Okay, okay. So question number 1. Okay. So they are asking that verify the Bonet's mean value theorem. Theorem एक minute. Mean value theorem for the function taken here, function fx is just equal to x. Function fx is just equal to x, and gx is what? And gx is just equal to e to power x in the interval -1 to 1. So we know that is what is the statement of the Bonnet mean value theorem. Let us see. So if fx and gx are bounded and integrable in this interval a comma b, and gx is positive and monotonically decreasing in this in the same interval, then there exists t in this interval such that is in this interval there exists a point t in this interval such that a to b fx gx dx is just equal to a to t of fx dt dx. ओके, यहाँ पर एक और फंक्शन होता है, इफ फंक्शन इज मोनोटोनिकली इंक्रीजिंग, ओके, एंड इन दैट केस दिस बोनो इज आल्सो हैव अ सेम रिजल्ट, ओके. सो इन्होंने जो है मोनोटोनिकली डिक्रीजिंग फंक्शन के लिए लिखा है स्टेटमेंट, स्टेटमेंट इज आल्सो होल्ड्स फॉर द मोनोटोनिकली increasing. So so you can also write some note for it. So I'm just writing a note for it. So note is it this similarly in g, if gx similarly if gx is monotonically increasing on this interval a to b, then it is monotonically डिक्रीजिंग इन दिस इंटरवल, ओके. अगर ये इंक्रीज कर रहा है उसमें तो obvious सी बात है, अगर हम इंटरवल को चेंज कर देते हैं बी टू ए कर देते हैं, दैट इज विल बी डिक्रीजिंग इन दैट, एंड बाय द सेम result, by using the same theorem, argument, there exists a point t dash in this interval a to b such that we have this is from a to b of fx gx dx is just equal to g times b integration from a to t dash, and this is your fx into dx. Clear? So we can apply here this one because यहाँ पर जो gx है that is monotonically increasing in this interval ना, so we can in this way graph of e to power x, okay, and fx is and both are bounded and integrable functions, okay. So let's verify it ki there exists some t in this interval which satisfy this condition, okay. So we are going to find that t or t dash whatever we just want. So let's start. तो कलर ग्रीन कर लेते हैं ताकि आपको. So I'm going to write the solution. Okay, so you can easily see here this both are function polynomial function, so it is a bounded function in the closed interval -1 to 1. So here fx is equals to x is continuous on this -1 to 1, okay. So we have fx is integrable, obvious सी बात है, it is integrable. If a function is bounded and continuous, then it is integrable. We have read the theorem, है ना, हम उस theorem को पढ़ा था, -1 to 1. Again, if talk about gx, so if gx I am taking gs, this is e to power x, okay, and it is monotonically non-decreasing. Non-decreasing. ध्यान देना, यहाँ पर जब नॉन डिक्रीजिंग है तो पॉइंट कौन सा ले रहे हैं, सेकंड सेकंड पॉइंट ले रहे हैं इंटरवल का, मतलब हम जीबी की वैल्यू लिख रहे हैं, है ना, नॉन डिक्रीजिंग, एंड इट इज पॉजिटिव, just a second, someone's came. Okay, so it's non-decreasing, and obviously but it is positive on this interval -1 to 1. So this satisfy the conditions of the Bonnet. Now we will have to find the some t which is belonging to this interval which satisfy the condition. So this satisfies the condition of Bonnet's mean value theorem. So now, so integration -1 to 1 fx gx dx is just equal to -1 to 1 x e की power x of dx. Okay, if you are going to find the इंटीग्रेशन, तो इसको हम फर्स्ट फंक्शन मानते हैं, इसको सेकंड फंक्शन मान के जो इंटीग्रेशन बाई पार्ट्स करते हैं, तो फर्स्ट फंक्शन e की पावर x, इसमें हम लगाएंगे लिमिट -1 to 1 एंड देन इंटीग्रेशन, इसका फर्स्ट का डेरिवेटिव 1 हो जाएगा और e की पावर x, और दिस इज -1 to 1 ऑफ dx. सो फ्रॉम हेयर यू विल हैव x e की पावर x, एंड यहाँ पर e की पावर x रहेगा, तो दिस इज लिमिट -1 to 1. नाउ अप्लाई द लिमिट, तो जब लिमिट अप्लाई करेंगे तो 1 हो जाएगा, तो दिस इज योर ई माइनस का ई, ये फर्स्ट टर्म हो गया, और दिस इज -1 रखेंगे तो -1 ऑफ ई की पावर -1 एंड माइनस ई की पावर -1, ये आ जाएगा. ओके, तो क्या आएगा तुम्हारे पास, लेट अस सी. तो ये तो हमारा जीरो हो गया, ये माइनस का हो जाएगा, माइनस का 1/e एंड -1/e, you simply have minus and -2/e, it means this is 2/e. सो तो इंटीग्रल की वैल्यू fx इंटू डी एक्स वो 2/e आ रहा है. अब हमें t फाइंड करना है, सो एंड some for t I'm just taking in this interval -1 to 1, so we have integration from t to 1 of fx dx is just equal to t to 1 of x into dx is just equal to 1/2, and here it will be x square. Okay, that is your t to 1, so here it will be 1/2, this is 1 minus t square. So what the Bonnet theorem is saying, so by Bonnet theorem, this function, this 2/e, it means fx into dx का जो प्रोडक्ट था उसका वैल्यू, और माइनस का g1, और फ्रॉम t to 1 of fx dx is just equal to e की पावर 2, दिस इज 1, माइनस g1 की वैल्यू क्या हो जाएगी, बिकॉज g1 की वैल्यू हो जाएगी g1 is just equal to e की पावर 1, it is simply 1. So this is your e actually, and इसका वैल्यू हमने क्या निकाला है, that is your 1/2, and that is 1 minus t square. So from here you can just, and that should be equal to 0. So from here you can easily see that is your e by 2 bracket में that is your 1, and Mhm. One thing is this, and this is actually this is 2 upon e, so it is wrong written here. So this is your 2 upon e. Okay. So now this is 1 minus t square and this is equals to 2 upon e. So अगर हम इसको ले जाते हैं, this is 1 minus t square is just equal to 4 upon e square, and because we want t here, so this is t square equals to 1 minus 4 upon e square, and that is equals to e square minus 4 upon e square, and you will get this thing. So this implies this t is square is just equal to e square minus 4 divided by e square, and this value will be lie between this interval. Okay, so you can say, or there exist t in this interval 0 comma 1, such that this condition will be hold, such that this condition from minus 1 to 1 of fx dx g1 just equal to t to 1 of fx dx. Okay. One thing is just correct here, that is this is from t dash to b actually. Okay, so just correct this thing. Lot of things in our textbook are incorrectly printed. Okay, so this is from t to 1. Okay, so this is follows the result. So this t is belonging to this interval. So we are going, we have to find this interval where this t is belonging to. Okay, so आई होप सो कि आपको चीजें समझ में आई होंगी और कैसे हम अपनी थेरम्स को वेरीफाई करते हैं। जो मोस्ट इम्पॉर्टेंट है, थेरम्स का स्टेटमेंट आपको दिमाग में रखना, बिकॉज जब क्वेश्चंस आएंगे आपके पास तो आप आसानी से उनको आंसर कर सकेंगे। ओके, सो नेक्स्ट लेक्चर के अंदर हम कुछ प्रॉब्लम सॉल्व कर लेंगे, एंड देन वी विल जस्ट रिकॉर्ड वन लेक्चर ऑन एमसीक्यू प्रॉब्लम्स, तो फटाफट वो हो जाएगा, एंड देन वी मूव इन द चैप्टर नंबर 4। Okay, so thank you for watching. We will meet in the next lecture for the next topic. Thank you so much.